Hi there, it's Federico here, and today I'll show you how to use LTSpice in order to simulate guitar effects and amplifiers. The first thing to do is obtaining an audio file, better if it's from a guitar, but mainly it has to be a .wav file, so something like this. And that's why LTSpice recognizes only this kind of file. Then we have to put this file in the same folder in which we have the project we are running. In my case, the project is inside the LTSpice my projects, and so I put the audio file here. Of course, then we have to draw the circuit, and mine is this. Well, the only reason it's hidden is because I personally designed it, and so I think you can understand. But well, we can continue. The next step is to set the input voltage generator. This is the input of my circuit, so right click, advanced, and inside the DC value we have to write wave file equals. Here we have to write the name of the file we want to use for the simulation. I remember you, mine it's corta.wav, so corta chan equals 0. Okay, and I also suggest you to label the input net, as it's always useful. Okay, now we have to write inside the spice directive this .wave test1.wav. We are going to generate a file, a wav file 1644-100, and here we have to write the node name. So where LTSpice has to take the signal. I want to take on the output, so I called it out. This is the output of my circuit, so I have to call it with the same name used for the node name, out. And this is important, otherwise you won't get the simulation result. Okay, now we can set the simulation parameters from 1 to 10 seconds, it's fine, and we can run the simulation. Okay, now we have just to wait a bit, and also for this reason I suggest you to avoid simulation longer than 5 or 10 seconds, as LTSpice takes a lot of time to perform this kind of analysis. Okay, the simulation I think it started. Okay, well, this is the input and the output. Of course, we can look at the waveform. So you can see the green line it's the input, the blue one it's the output, and you can actually see how the effect changes the signal waveform. Okay, another important thing to know is this. 16 is the bitrate, while 44-100 is the sampling frequency. Okay, zoom fit. We have to wait just more than a few seconds. In fact, I'm going to stop the recording and skip to the ending result. Simulation is ended, so I can show you the simulation result. This is the generated file. And this was the original. So that's all.